Okay, can everyone hear me? Yes, perfect. Okay. Ooh, okay. I'm Tom, and I'm going to be talking to you today about optimizing drawing. A couple of points of order before I get going. I'd like to thank the organizers for inviting me to come and talk. I'd like to thank all of you for being here as well. The conference is pretty useless without an audience. I speak quite fast as well. So people have told me this, native English speakers, my natural sort of cadence is quite fast, especially when I'm excited about something. And I'm quite excited about this topic. So I try and talk quite slowly. Yep. Stand here. Okay. I also move around a lot. Yeah, I talk quite fast. So I try and lower my cadence. Sometimes I might talk pretty quickly and get excited. And I'll try and roll back and repeat what I've said. So apologies if that happens. And lastly, this is my first keynote ever. And maybe my last. I don't know. We'll see how it goes. Hopefully not. But I hope you enjoy it. So this is the... Okay, here we are. This is the table of contents. These things are awesome, by the way. Yeah, this is the table of contents. So I'm going to start with introduce myself. Then I'm going to waffle on about some philosophy kind of stuff. Then we're going to get into the interesting technical side of things. And then I'm going to wrap up. This is also the first talk I've given that isn't purely based on technical stuff or a project I've done. So hopefully the message comes across. But let's find out. So who am I? I'm Tom. I started to code when I was 14, playing a game called Counter-Strike Source. Anyone in the audience ever play Counter-Strike Source? Ooh, okay, this is the most people I've ever had. Must be quite popular in Portugal. Yeah, so you could build mods in Counter-Strike Source. You could build, you know, ones where you would, it's a first-person shooter. You kill an enemy, and then you maybe get a new gun, right? Or you would have zombies versus humans. You can modify the game, and someone in the audience remembers that. Yeah, it's kind of fun. And I was like 14, and I found that I could type these kind of things into this file, and fun stuff would happen, right? And that was incredibly engaging. That got me into programming. And gamification in general is like a fantastic way of learning. I saw a YouTube video about some kids. So the stuff I was doing in Counter-Strike is basic. I saw a YouTube video that blew my mind. It was some young adults and teenagers in Minecraft. They built a computer in Minecraft, right? So you can use redstone blocks. I don't play Minecraft, so I don't know much about it, but you can build transistors basically. So they had figured this out and they built a computer. They built a functioning CPU, a functioning graphics card, all of the stuff that needs to tie that together, a screen, and they used it to play Minecraft in Minecraft, right? That's crazy. And I want to keep this in your head as we go through this talk. Do you think that they could have done that if someone was telling them to do that? Or if someone was like, you know, if they were reading a book on how to make a CPU in Minecraft? They did it by themselves. They found joy in that and they kept going and they built something that was incredibly impressive. So keep that in mind. But programming in general is fascinating. I find it fascinating now. I found it fascinating then. Out of interest, who here started programming like by themselves? As in, it wasn't at university. Say about 50%. So it's a very common thing, right? And there's something about programming that fascinates you, or it did at least me. If something got you into it and you didn't think, oh, this is boring, you know? Oh, I can print hello world. Cool, that's lame, right? There's something about that you felt was cool as hell. And that's fascinating. It's fascinating at like the micro level, right? So you can zoom in. How does everything actually work? How do the nuts and bolts fit together? You know, you've got a whole wide variety of different things. You have, you know, you've got a bit of physics in there. You have theoretical maths, you have a bit of philosophy. You have a gigantic pile of hacks from the 80s and legacy design decisions that kind of fit together somehow, and they form like a cohesive whole that we can hold in our hand and we can use that changes people's lives, right? And you can zoom in and you can keep zooming in as much as you want, into as much detail as you want, in any part of this. And that's fascinating. But then it's also fascinating to zoom out at the kind of macro level. So like, how do we organize ourselves, right? We know how to build a thing, but how do we actually build it? Like, how do we organize teams? How do we agree on the changes? How do we define boundaries and interfaces, et cetera, et cetera? And then there's a mix of both. You have the fascinating side of things where, you know, the solution at the zoomed in level, the most efficient solution, we've probably all been in this situation. We design something that's really great, performant, but it turns out it's the wrong thing. Or that solution is not best for the business, the stakeholder, the entity that is ultimately paying you. So there's a tension between the best, and the best at different levels is a different thing. And then you have sometimes exciting new things that come and just disrupt both sides. They disrupt how we build software, like physically the nuts and bolts, and they disrupt how we build software in terms of how we organize ourselves, how we actually build the building of the software. I guess it's fascinating. It's all fascinating. It's a discipline that's always evolving, and one that you can keep learning as much as you want forever, and you'll never ever learn any amount of it, which I think is good. I enjoy that. And yeah, as I said, some people get that. Some people, when they start coding, they print hello world and they see the possibilities. They see something that hooks them on. They find something joyful about it, I think. This talk was originally called The Joy of Coding. When I accepted to give this talk, and I came up with this title, I kind of got it in my head, and I was like, okay, we'll talk about the joy of coding. I like coding. Okay, so it's easy to talk about, right? I'll get up on stage and I'll say, you know, talk about well-structured class hierarchies. I'll talk about clean code, linting rules, CI pipelines that never fail, a Jira backlog that, you know, has an end in sight, right? Something like that. It'd be easy, right? When I actually started to think about it, I had no idea what the joy of coding really was. It's pretty hard to define. Like, why do we enjoy what we do? Why does anyone enjoy anything? Right? Kind of went down an existential crisis. Do I enjoy coding? Like, maybe I don't. My life is a lie. I mean, why are you all here at a conference where we talk about code? It's maybe a bit weird sometimes if you think about it at one level. It's fantastic that you are, but we clearly enjoy it enough to spend our time talking about it when we might be doing other things. And code is also ephemeral, right? Like, some code definitely lasts for too long, but a lot of code is deleted and refreshed quite quickly. You know, you might write something, you spend a week doing it, and it might be gone the next day. It might not work, right? Roll back immediately. Or it might be gone in a month. It's not physical either, right? You can't feel it, you can't touch it in most cases. What's joyful about that? But coding is enjoyable. Like, I enjoy it, I know that. And what I realize is that there is no inherent joy in coding, right? So very few things have inherent joy in it. It's all subjective. And you might watch this whole talk and you might disagree with all of this. You might not see what I'm trying to say, or you might find joy in different things than I do. This is my personal take on this. And the point of this slide is to say, the coding, what's enjoyable and what's not enjoyable depends on who you are, which might be obvious, but to illustrate this, we'll talk about parquet flooring bricks. Parquet flooring bricks are small bits of wood that form a floor like this, I guess. My dad, when he was refurbishing our house when I was like 6 or 7, and I don't know if he did this on purpose, maybe he's a genius, but he had this pile of these bricks, and me and my brother got hold of them and we started building with them. They were kind of thin rectangular bits of wood. And we figured out that you could build, I mean, at the time I was probably that high, but we could build structures that seemed that high. As high as we were, you could build these towers, you just ground things, and then you could just smash them all down and rebuild them, right? There were these endless possibilities in these, what's essentially like waste bits of wood. And he was a genius because Lego is super expensive and those cost absolutely nothing. And we got so much joy out of these parquet flooring bricks. So when I see parquet flooring bricks, that brings me joy. I have joy associated with that. Whereas you see them, or most people probably see them, as bits of wood, right? And this is the problem with the title. It's the things you do with coding that bring you joy. There's no inherent joy in coding itself. There's subjective joy, and your experience will always differ from others. This, like in summary, it's not the joy of coding, it's the joy of having coded. And there's a difference, because it's all about the outcome. The outcome is what's important. The outcome is what brings you joy. It's not how you get there. It's not your linting rules. It's not how clean your code is. It's not how many tests, you know, how well or how elegant your functions are, how well you build them. It's what you build. That's what brings you ultimate joy, in my opinion. And that's what gets you hooked in coding. You have that print world, like print hello world, that's a program. You summon that out of nothing. The outcome is what brings you joy, not the print statement or the string or anything like that. It's not the code, it's the outcome. The problem that I see is this. As you gain experience as a developer, satisfying and joyful outcomes get harder to achieve. You know, print hello world is the first thing that many of us probably did. It's also the easiest. You do that now, who cares? But at the time, that was amazing, right? That got you hooked. And once you print that hello world, you find it satisfying, and you fall into this like joyful feedback loop, is what I'm calling it. The more you learn, the more you want to learn, and the more you're able to learn. So you print hello world, cool. What happens if I change this bit of string between these two quotes? Oh, something else prints out. Okay. How about I print it 10 times? Oh, there's a for loop. I understand that now. And you get this intuition. You grow and you're able to learn more, and there's more to explore. But yeah, as you do this, it gets boring, right? No one here is excited, likely, about a for loop anymore. Those are just nuts and bolts. Your brain kind of seeks novelty. It seeks new ways to apply new things. And I think that there comes a point, that certainly did for me and other people that I've talked to, as a developer, where you know enough to do things, right? You are good at your job. You get the outcomes that your company wants. You get paid. Everything's fine. But you forget about the joyful feeling that you had, or you lose that joyful feeling that you had when you started programming. And your learning kind of slows as a result of that. And I think that's a shame. So this talk is aiming to discuss this and to answer the question, how can we get that feeling back? So one solution might be to read lots of programming books, right? So you're a developer, you want to get back into learning new things, you want to energize yourself, you want to learn something. And you think that by learning something, you'll build something that will bring you joy, and you'll get back into that loop. So read lots of books on programming. This is where the sort of subjective side of things comes into the talk. I lived in Lisbon for 4 years. So Portugal has a special place in my heart. But after the first year and a half, I signed up for a Portuguese language course at university, which Portuguese is a very difficult language, and I'm English, and I don't speak any other language. But I figured I want to live here for a while. I think I should speak the language. So I signed up for like I think it's an A1 course, like the just ultimate beginner university course, paid the money, went there, and I was like, okay, I'm motivated, let's do this. Like I want to learn. The first lesson was one slide on você, if that's spelled said correctly, like the tenses and formalities and the to be verb. And then there were like 30 slides on all the exceptions and how those rules don't apply and blah, 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 blah. So I was like, okay, cool. Similar to JavaScript, maybe. There's lots of weird quirks that you probably don't want to fall into. Fine, I can learn those maybe. It's cool. The second lesson is where it all went wrong. So the second lesson, we had a class exercise where we had to write a conversation about the weather. And I'm English, we like talking about the weather a lot. So fine, okay, I just took what I know, read the book that they gave us. As a side note, there's a law in Portugal that means all textbooks need to be written in Portuguese. This is how the teacher explained it to me, including A1 Learn Portuguese textbooks. So the entire textbook was in Portuguese to learn Portuguese, which is made it quite difficult. But I kind of went through this. I wrote some stuff down. I was one of the last members in the class to present everything. Everyone before me seemed to do okay. I mean, I didn't really understand what they were saying, but the teacher was, someone got a clap. It seemed good. When the attention of the class and the teacher turned to me, I realized that what I'd written was complete nonsense. Like it just made no sense whatsoever. And I was sweating, I was nervous, and I didn't get a single word even slightly correct. Like my pronunciation is not fantastic even for English. Pronouncing stuff in Portuguese is is a lot. And what was weird was at that moment, I wasn't like a 29-year-old functioning adult. I was a child back in school, back in secondary school. And I disappointed the teacher. I didn't know anything, and I couldn't grasp the concepts that everyone else was getting. And everyone knew that, right? Everyone's attention was on me. And that feeling, I completely forgot about that feeling. But I had that as a teenager. I think maybe everyone goes through that kind of situation at one point in their lives. I thought that was behind me, but I was there. Like some kind of memory nightmare thing. Hated it, and I never went back to the class. It put me completely off. What I realized is it's all about the outcome, right? And it's about the right outcome. So I thought the outcome was to learn Portuguese. That was my idea. Learn Portuguese. Cool. Get the book, read the book, have a university person help me with the book. But that wasn't the outcome that I should have been looking for. The outcome should have been order at a restaurant, have a conversation with some friends about the weather, right? Not start from the fundamental building blocks of Portuguese. I'm probably never going to talk to the Queen in Portuguese or someone super high up. So maybe I don't need to learn all of the formal tenses, maybe. Like there's parts of it that I don't need to know. But if I started small, then my confidence would have grown. And I would have got into this loop where I would have enjoyed learning. And the more Portuguese I would have learned, I would have got my confidence, and I would have been able to talk more, and I would have wanted to. But I was trying to learn Portuguese, like reading, I don't know, university textbook on programming before you've written Hello World. And then when the first syntax error pops up, cry about it and run away and never do it again, right? Some people do learn via like reading books and reading dense textbooks on various things. If you do, then that's a fantastic thing. And you're lucky. I'm quite envious of you. I don't at all. I need to play, I need to feel, and I need to explore when I learn. That's what gets me to learn things. And that may seem obvious, but if you don't realize that, it can be quite distressing. You think that like you are the issue and you should know things, etc. But really, it's the way that you are learning them, right? So if you've ever been stuck on a problem or a technology that all of your colleagues know, or you feel like everyone gets and you just don't for whatever reason, maybe it's the way that you're trying to learn it is the issue. And maybe changing that approach of how you learn things would enable you to learn them more effectively. So, okay, why don't we try and learn these kind of things at work, right? Why can't we get into this joyful loop at work? Why do okay, reading textbooks at work, fine, cool, but we can also practice at work, right? We all work as developers, or a lot of us do. We get paid to code. So let's get paid to learn while we code. And you can, but your company will ultimately pay you to learn things that benefits them. That's it. There's value in to you personally, in knowing more than one programming language, right? It teaches you new ways of thinking about things. It's a good thing to know. But if your company only uses one programming language, they're pretty unlikely to pay you to learn code, or I don't know, Java or something, whatever you fancy. So your learning is ultimately shaped by what they get out of it, the value that they receive at the end of it. And it's also work, right? Like it's work. So you need to fit into how your work builds software, which might be, a particular repository structure. It might be pull requests, test coverage, a CI test setup, security audits or whatever, right? Like all of this is work stuff, and it's important work stuff, but it gets in the way of learning, right? It's forcing you to learn in a particular kind of way, and that doesn't work for everyone. And it can be harder to fall into that joyful loop. For me, side projects, they're the solution. Side projects are a chance to do something you want to do in a way that you want to do it, unconstrained from, having a manager or having to build code that's maintained by others, right? Having to write tests, it's a way of expressing yourself and doing what you want to do. There's a problem with that. Developers are famously terrible at finishing side projects. Okay, raise your hands if you consider yourself to be bad at finishing side projects. If you started a bunch, okay, so basically, yeah, everyone, right? You're not meant to finish, yes, but you're not ever meant to finish, and this is actually part of the talk, but you are meant to reach milestones, right? If you drop a project because, because you lose interest or you don't fall into that joyful loop where you want to learn more, then it's not good, right? What do you really learn? Maybe it puts you off learning that thing entirely. This solution I'm going to call Optimizing for Joy. This is like a name for a series of things that I found that helped me personally in doing side projects. And by doing these things, for me personally, I learn more than I've ever learned at any work, any job, any position. I've learned way more than I have done reading any amount of blogs or textbooks or going to anything, right? It's personal enjoyment of something. And they also might seem glaringly obvious, but I've never seen them written down or spoken about. So I decided to do that as part of this talk. Optimizing for joy. So the number one thing is don't start out with a specific goal in mind when you have a side project. So set out to explore or investigate something. A lot of people, when they do side projects, set out to do, I want to learn Django. I want to learn X. I want to learn something. And then they go on the blog or the tutorial or something, and they're like, okay, I'll build a blog with Django. I'll follow the tutorial. Then you get to the end and you're like, oh, okay, I've got a blog. I already have a blog, but now I have one in Django that I can't run, right? It's not particularly engaging. So don't start out with a specific goal. Set out with some ideas about things you want to do or some constraints, but keep it flexible. So you do this by asking a why or what question that seems interesting to you. Then you start to answer that question with an MVP as quickly as possible. And this is key. It has to be as quickly as possible. You do this by dropping anything and everything that doesn't get you closer to that MVP. MVP is minimal viable product. So the absolute smallest thing that would begin to answer that question that you have. And once you have the MVP, you rebuild it or you ask a new question. And that's the loop. So you take what you've learned in building the MVP and you make it better, right? You improve it, you iterate on it. By this point, you should have something that sparks your interest, right? You have something physical that you can hold or run, something that maybe is horrible. The code is terrible. It barely works, but at least it kind of works, right? Or maybe you get there and you realize the question was stupid, right? Or it doesn't make sense, or there's a good reason. The answer is no, for whatever question you've asked. Maybe you've learned something along the way that you can then use to ask a new question that interests you. And I'm going to go through a side project that I worked on that you chose this, I think, one that I'm quite proud of. And this is the section of the talk called Committing 1 gazillion lines of code to GitHub over the weekend. Okay, so some of these slides are going to go quite quickly. Lots of screenshots. I don't like very dense slides, lots of code. I like pictures. So we're going to go quite quickly. If you don't have to read all the text on this, it's not really important. But this started with, I was doing something else, and the answer to the question that I was trying to answer required me to get data from PyPy. PyPy is the Python package index. So it's one of the largest in the world, and it's got all of the Python code that's ever been published there. And I wanted to do some analysis. Right? I wanted to count how many releases were made every day or something like this. In order to do that, I went to the official PyPy documentation, and it said use BigQuery. So sign up for a Google account and use BigQuery. Google BigQuery, it's Google's planet scale data warehousing solution for scanning petabytes of data in nanoseconds. In order to sign up for it, you need a credit card. I don't have a Google account, and I didn't fancy doing that to scan what I thought was a very small amount of data. Why is it difficult to get data from PyPy? I wondered. Like, why do you need to use BigQuery? Is the data so gigantic? So I set out to answer it. And I built this. This is PyPy JSON data. And it's basically just a repository that contains all of the API responses from PyPy. So there's like 500,000, 600,000 projects in PyPy, 600,000 JSON files in this project. It works by having a GitHub Actions cron job that runs every, I think it's 3 times a day, and it will fetch new releases from PyPy. So it finds out what new projects or new releases have been uploaded to PyPy since the last time it ran. It then goes to PyPy, gets the JSON response. PyPy has an API. It says, give me the data, all the data you have for it. And it just commits it to the repository itself. It commits it to itself. It adds it to its database, which is a Git repository. Then you, as an engineer, or someone who has a question that requires all the data from PyPy, can use this rather than have to build this, right? To scrape and make hundreds of thousands of API requests to an API that sometimes is quite flaky. Cool. There's also a SQLite database. This is 2 gigs of data, and you can download it and you can query everything. We don't need BigQuery is the answer to this. Cool. I mean, awesome. I went on my merry way and did something else. Then I got a pull request from this dude. This is a guy who works for Infosys, which is a large consultancy. And when I got this, it really confused me because, like, what is this? Do these cats sit on the keyboard? Like, I don't understand. He was trying to delete a project, like one of the metadata files. So one of the API responses from PyPy, the project was called IHIP. The project had been deleted from PyPy, but the data, the metadata, is still in this project. So he clearly went on GitHub and searched for IHIP, whatever, and he found this and he did that. The reason he did this was because he wanted to get rid of, like, the metadata has a homepage in it, and that homepage pointed to like an internal GitLab index, a GitLab.infosys.com that they didn't want to be public, right? So, I mean, you could write that in the description, but whatever. And this is part of the diff. I looked at this and I thought, interesting, the project's not available on PyPy anymore. Why can't I just download this? Like, this, does it work? It does. PyPy doesn't delete things. So if you, and for good reason, if you delete something on PyPy, it removes the database entry. The files are still there. And that's because they're mirrored immediately. Removing them would give you a false sense of security. Those files are still existing. You can still download this today, even though the project has been deleted. Interesting. Took a look at the files and I unzipped them. And immediately, straight away, found an AWS access key. He didn't know about this, by the way. This is like a very big coincidence. So I found this, and if you're not familiar with what an access key is, an AWS access key, this is not good. Think of this like a username and password, almost. This should not be in your code, for sure. And it shouldn't be there. This was actually a full admin access key as well, which is even worse. And it was for an account that contained some kind of COVID-related data, and it was just chilling. The project had ended ages ago. Just chilling there for ages. So complete fluke. But then I got thinking to myself, why is it possible to publish credentials to PyPy like this? Like, couldn't we stop it somehow? So working this out seemed interesting to me, right? This is an interesting thing. Like what, honestly, why is it possible? You can just put anything you want in it, right? Can we stop it? What even is a credential? How do you detect it? There's lots of depth to this. And I'm generally interested in the outcome. My first job was actually working for a developer in a security company. I presented at security conferences. I like security. This topic interests me. So let's find out more about it. Why? This is a regular expression from the AWS documentation to detect an access key and a secret key. So these are the official regular expressions. Regular expression is a string like this. It's a pattern. You run this regular expression over a lot of text, and it will tell you what bits of text look like an access key and look like a secret key. Okay, so we just need to run this regular expression on everything that's uploaded to PyPy. If your code contains this, show a warning or something like this, right? Problem is, the secret key bit there matches absolutely bloody everything. It's a lot of stuff. Okay, so we can prune it down, right? Why don't we have an access key with quotes surrounded by a secret key with quotes? You know, if it's a secret key, like with the example we've just seen, if it's surrounded by Python quotes, it's more likely to be an access key and a secret key. We can reduce the number of like false positives that we get. Okay, that also matches everything, unfortunately. Fine, okay, so big brain time. We are gonna look for an access key with quotes followed closely by a secret key with quotes. So these quotes, these are two things closely together. If it's within like 4 or 5 lines, They're probably the same thing, also matches everything. And what if it's an access key? What if it's a secret key with quotes followed by an access key with quotes, right? And like you can keep going, and it just ends up looking like this. I mean, this is horrible. It makes no sense. I mean, generally, same thing. Horrible. And this is for just one type of credential, right? This is just one single thing. GitHub has a secret scanning thing, and so does a startup called GitGuardian, and they support 230 and 350 different types of credentials. They use regular expressions and a number of other ways to detect these things, but they have built a whole company around this exact problem, right? This isn't something that you can just solve by yourself in a way that works. Then I got an idea that I couldn't stop thinking about. Why can't we take all the Python code ever published to PyPy by every person in the history of the world and push it to GitHub, right? And then GitHub can scan that code. I don't have to write horrible regular expressions. I can just take everything, shove it on GitHub, and GitGuardian or GitHub can do its job, right? Git is perfect for this as well. The more I thought about it, it really is. And let me tell you why. What are Python packages? So projects have releases. Releases have many files within them, right? So these files are archives. They're basically zip files or tar files. So the wheel files, WHL, are zip files. And the archives contain actual code within the release. But when you think about it, most of the code in the 9 million plus release files that are on PyPy, they're not unique, right? So think about Django. There's a bug fix release of Django, Django 4.2.2. They fixed a regular expression issue, actually, with a validation. That changed, that added one test, and it changed one line of code. Otherwise, the code is identical to the previous release. And that previous release is pretty much identical to the one before it, et cetera, et cetera. The set of changes between each release is not big. And more importantly, if you think about it, like Django release 4.4 or whatever, 2.2 even, the two files, the archives, the code within that should be identical. If it's not identical, if there's like one file that's been released in a wheel file, but not a zip file, not a source release, like two different release files for the same version with different code, that's a red flag, right? Something has gone wrong there. But otherwise, they should be, in the ideal case, identical. So most of it's not unique, and we can verify this. So this is me dog fooding my own project to grab all of the metadata for Django. I'm extracting all of the URLs for all of the packages and all of the releases in Django, and I'm downloading them locally. Cool. Then I am extracting them all. So I'm using a tool called unar, which is fantastic. I always forget how to unzip and untar things on the command line. Unar just does it for you. So throw it at that, unzip everything, and we can count the number of files. So we have 2.6 million files in total. So that's all of the Django code ever released to PyPy, 2.6 million files. How many are unique? We can compute that by taking the hash of every single file. And there are only 64,000 unique files. So of all that code, the 2.4 or 2.6 million, only 64,000 are actually different, right? Not to say that they're similar, they are unique in terms of the hashes. If a file's hash is the same as another file's hash, the contents are the same. So 2.3% of the files are unique. And that's quite a big reduction. What happens if we stick it in Git? The size goes from 15 gigabytes to 970 megabytes, sorry, when the unique files are taken into account. When you shove that into Git, it becomes 0.3% of the total size of the Django code. And this works by using Git, right? So Git stores only unique files. That's kind of how it works. And it also compresses similar files. The whole idea is you have some code, you make a pull request to change one line of code. It doesn't store an exact copy of the file, right? It stores the diff between the two, the delta. And that's how it's fast. PyPy has a lot of duplicate code, and there's a small number of changes between each release. And this works by pack files, basically. I'm not going to go into this, but pack files are pretty awesome. All of the files in the repository contain one or more pack file. They get compressed into it. And it's kind of like a tar file almost. You can copy them around, you can extract them, you can read from them. Attempt 1. Here's the plan. We're going to rent a server. We're going to write some code. We're going to run that code. We're going to push the results to GitHub. And we're going to live happily ever after. We're going to be joyful. And this is some pseudocode, basically what I wrote. We're going to loop through all of the files in PyPy. We're going to download them. We're going to add them to Git. And then we're going to push it to GitHub. And here's me. Real photo of me setting off on a journey. I'm ready. I wrote the code. I got it going. Wrote everything. I was happy. Blah, 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 blah. Oh, no. Okay, shit. GitHub turns out there's a limit to the size. And they are going to ban me very quickly if I don't delete that 150 gigabyte repository that I just pushed to them. The limit, always read the documentation, is, I think it's 5 gigs is what it says. And they will take that very seriously. Okay, I had 5 days to delete it. I was sad, fine. Okay, I'll get around to it, right? Then I kept getting more emails from people telling me that I was hacking them and they were going to sue me. And why are my secrets all in this GitHub repository that you have, right? This one is particularly galling. That project had been there for a very long time. And they were sort of pointing out that all their credentials were in it. They weren't. I mean, they were in PyPy, but putting it in GitHub had helped them in some way, even if they wanted to sue me for doing that or threaten me legally. So the problems with this, managing a server sucks. So after this, I mean, I kind of lost interest, right? Like, it wasn't fantastic, didn't work, GitHub banned me, etc. The problems with this, managing a server sucks and it costs money. So renting a server, the server's hard drive died when I was doing this, downloading all of the packages. So I needed to obviously recreate it. I don't want to do that more than once. Okay, so I'll spend some time writing a Puppet script and a bunch of automation to spin up servers, etc. I'll do that, fine, did that. Wasn't fun. Running the repository took like 70 hours to produce this thing. And I was hyper optimized on getting that time down. I thought that was the problem that I wanted to solve. So I spent an insane amount of time running all this high performance Rust code, hyper optimizing every little thing to get Git to build this repository, this pack file, as quickly as possible. Git commands became unusably slow with a 150 gigabyte repository containing, nearly 1 billion files. Like it's not what it's built for, really. And GitHub nearly banned me, and everyone threatened to sue me. So overall, like, motivation, 0, stop working on it. And how do we do on my Optimize for Joy checklist? Well, I asked a why or what question, started well. But I didn't build the MVP as quickly as possible. Like, the MVP was pushing it to GitHub, and then it all went wrong, right? I was focused on the wrong things. I didn't drop everything that got me closer to MVP. I spent time managing servers. I spent time building Puppet scripts. I spent time optimizing, going from 75 hours to 70 hours. Yes, fantastic. Sounds good, right? Saving every possible byte off various things. And I didn't get to ask a new question other than why did I spend all this time doing that? But then I got this email from someone who didn't want to sue me. And he said, thank you, right? Thank you. We published these credentials to PyPy. And thanks to you, we found them and we removed them. That was really nice. And that kind of spurred me into trying again. Attempt 2. There are 9 million release files on PyPy. If you split them into chunks of 40,000, you get 230 Git repositories. Then GitHub can't ban you. And this is how it works. We have a controller. The controller runs another cron job using GitHub Actions. It reads from the projects that I wrote before, the PyPy JSON data. It reads new projects after, the previous time it ran, and it assigns those projects to a repository. So it adds them to the repository, adds like a something to a JSON file that exists in the repository, saying these packages exist in this repository. And this is the big list of repositories. There's a lot of them. Then inside each repository, there is another cron. I love cron jobs. There's another cron job that runs every day, and it looks at new projects that have been assigned to that repository. It downloads the releases from PyPy. It extracts all of the lovely code inside, and it commits it to itself. And what's big brain about this is you can do this, the entire thing is distributed, right? Across 230 repositories. So you're 230 times as fast as you would be doing it on one big server. It worked. And here are the results. All new PyPy uploads are automatically scanned for secrets. I pushed this package 2 days ago. No intervention. It's now on GitHub. Same as any other code. When you commit a secret to GitHub or to PyPy, that gets committed to GitHub. GitHub will scan it. If it contains a valid key or something that looks like a valid key, it tells the provider of that key. So if it's an AWS key, it will notify AWS that these keys exist in this repository. AWS will send you an email, they'll open a ticket actually with you to say, these credentials exist here. There's a policy that's added to these keys to prevent misuse. So it prevents people from spinning up servers and doing things that you definitely shouldn't do if a key is valid. And the same goes for any other provider. So PyPy themselves are one. So if there's a PyPy token that's added to a PyPy project and published, they know about it, they revoke the key and they email you. PyPy now fits on a memory stick. The total size is 360 gigs for all of the repositories combined. And you can buy, apparently, and I was quite surprised this, you can buy a 512 gigabyte memory stick, which is pretty nuts, I think. I don't know if this is a real memory stick, by the way, it could just be some fake one, but it looks real and you can buy it. And if you did, you could stick PyPy on it. I broke Git Guardian. So Git Guardian is one of the third-party like credentials, they scanning services. They scan all of the public commits to GitHub. And I decided to do this on Sunday when I pushed that button. When everyone in Paris, their French startup, was asleep. No, they weren't working. And then they got all these alarms, and I committed so much code that it just completely screwed the entire installation. So I'm very sorry about this. Anyone can get a Guardian. Sorry for making you work at the weekend. And also the way that I did that with the individual repositories bypassed some of the protections they had in place for stopping this exact issue. So inadvertently caused a bunch of issue. However, things that Git Guardian and GitHub found were quite interesting. People have published a lot of credentials to PyPy. This guy, or this person, committed not one, not six, 209 OpenAI keys. Now, what's interesting about this, and this is a general theme with a lot of these issues, this file is an accidentally added markdown file that only exists in one single release for this package. So this doesn't exist in any other release for this package. They've, at some point in their publishing process, they fat-fingered something or something went wrong, and it bundled a file that should have been excluded, or a directory. And that directory happened to include a whole lot of OpenAI keys. Same with PyPy tokens, right? So this guy has committed a PyPy token that's valid. By accident, I assume. This is a fun one. This is a very recent one as well. Yeah, clearly not. Even AWS has done it. So this is the official Amazon Pay SDK. It contains access key. And this, again, is a single integration test file that only exists in this one release. So the developers clearly working on this. They decide to publish. They forget to exclude it. It wasn't excluded, whatever. The next release, the other actual file, so this is just one, this is the source distribution, the wheel distribution, doesn't exist. It does now, and it always did. These are all of the credential types, the live credential types. So Git Guardian will check the credentials, and it will find out if they are valid or not in a non-obtrusive way. There are a lot of them. And this is the set of all of the names of the providers that it's found live keys for. So there's Coinbase keys in there. We have PagerDuty keys. We have valid SSH credentials, Datadog API credentials. There's even Azure Active Directory credentials in there somewhere. AWS keys, Postgres credentials that work for valid servers that exist. And they're all in there. And the problem's getting worse. We can chart it over time. So obviously the number of uploads to PyPy has increased a lot. So percentage-wise, it's gone down. But the absolute number of individual projects, not releases, unique projects that contain live credentials over time has, well, it's gone up a fair bit, quite a lot. Side project done, joy achieved? No. Once you build the MVP, rebuild it or ask a new question. So why do we need to clone these repositories to analyze the contents? So I want to have a look at some stuff, but do I have to clone a 320 or 230 gigabytes, 230 individual Git repositories consisting of 320 gigabytes of contents? No. So build a data set. Every time the cron job runs, every file that's added or not added gets a line in the data set. The data set has the hash, so it's the unique contents of the file, number of lines, the path, the project name, release, version, the upload date, the size, and if it's been skipped. We don't commit binary files to Git, right? Git's not built for that. So any binary files and a few other specific ones I'll skip. And if they are, the reasons are recorded in there. So you can now query all this data on your local machine without having to download it. So here we're like counting the size of all of the files by the file extension. So SO files, binary files are the largest, Python files, 4.2 terabytes. In total, 1 billion files in PyPy, 322 billion lines of text, 60 terabytes of actual unzipped data, and 3,000 new lines of code added per second last month. And that's going up quite a lot, which is it's more than I expected. I found that interesting. This is my favorite bit of the talk. Are you ready to see the pinnacle of Python engineering? Are you ready to see the longest Python file that's ever been created by mankind? Yeah? You ready? I present to you even or odd.py. $20 million lines. This is real. You can go and download this if you want. I hope it's a joke. Really hope. Yeah, genius. But that is by far the longest Python file in PyPy by an order of magnitude. The most complex Python file ever constructed is this one. And it contains an expression with nearly 55,000 components. And you can't parse this. Python Stack Overflows, libcst Stack Overflows, it's a mess. It's auto-generated by some kind of SAT solver or some tool generated this. There's a few of them like this from the same project. Thought it was cool. It's the longest Python expression ever. We can also look at ecosystem trends without having to download stuff. So what about setup.py versus PyProject? So we can chart this over time. And we can see very soon the usage of PyProject.toml will overtake setup.py, which I think is interesting. So it's clearly more popular. We can segment this by classifier, right? So we can say in the machine learning space or for individual contributors, as in people who have published sort of a one-off package, is it more popular? Is it more mature projects that have this? We can look at how Python is evolving over time. Markdown versus RST, for example. I mean, Markdown clearly won, clearly. RST is not as popular. We look at the projects by size. And if we find out, if we look at this, 16% of all the data on PyPy is TensorFlow, which is more than I expected, right? For a single project from a single company. It's a lot. And I mean, if you look at most of these, they're all sort of ML related things. There's a reason for this. ML stuff requires wheels. Wheels are big, lots of binary machine learning things. Python packaging is a bit of a nightmare at the best of times. So in the result, 16% of all Python data, PyPy data is TensorFlow. It's also mostly binary files. So, I mean, you know, there's 14 terabytes of actual text in PyPy. There's 40 terabytes of random binaries for various projects. All right, cool. Why can't we parse the files themselves locally? Right, like we've looked at the metadata. What's actually in the files? So here I am. I'm running a tool. I haven't made this open source yet, but it uses the Git repositories I've cloned locally. It runs a regular expression over them on my local machine. And I'm scanning every single Python file that's ever been uploaded, or every text file that's ever been uploaded to PyPy, to find Stack Overflow links. And these are the most common Stack Overflow links in PyPy. So the idea behind this, I mean, honestly, these aren't as exciting as I thought they were going to be. I thought there was going to be one or two that quite stand out. But the idea behind this was, is there some kind of questions that people are linking to that could be fixed in the language themselves, right? If there's like 1,000 people asking, how do we find IP addresses using Python standard library? Maybe that's a good standard library inclusion. We can use this data to drive the evolution of Python by looking at how people are using Python. We can look at language features. So by parsing this, we can look at how many projects are published that contain code that uses f-strings, that uses type annotations, f-strings and type annotations, the most popular adopted Python syntax additions ever. Nearly 50% or over 50% of all projects now published contain either of those, which is a lot. F-strings were quite contentious with the language. People were like, do we need another way to do format strings? Like, why add these? And it was a contentious decision. It's clearly the right one. People love them. What do we learn from that? Can we improve them, right? Maybe we shouldn't be focusing on other things that potentially don't have as much usage. What is the best way to share this with the world? Cool, I had all this data. I mean, I could do a presentation like this, but like, is there a better way? Let's build a website, pycode.org. You can visit that now. It contains all of this, basically, all of the graphs, all of the data, live updated. There's a searchable list of all PyPy projects in your browser, no backend. It's a big flat static site. You can click on one, type it in. You can then view the code. So you can jump directly to the GitHub repository that contains this code. There's stats. I like graphs, lots of stats. So this basically, some of the screenshots I've just showed you come from this, right? These are all live updated every month. Everything's analyzed again. These graphs are re-rendered. So we have language features, we have secrets detected, we have releases over time, like charting this. PyPy is growing quite significantly. Largest projects by size, stats by extensions, files not added to GitHub for various reasons. There's even an in-browser SQL tool. So you can run any SQL query about downloading any of the indexes, view the results in your browser. So we've gone from, I need to use a planet scale database to query PyPy metadata, to, I can parse all the code ever published to GitHub, to PyPy on my laptop in a few hours. And not even mentioning the fact that all new code and historic code is scanned for credentials, preventing accidental leakage. This is the joy of coding for me. I did this from my living room, right? I got into the best joyful loop that I've ever got into. And I kept asking these questions, solving a real problem. And the more I solved, the more it interested me, the more I wanted to solve various things. All of these questions kind of chained off each other. And I learned a whole lot along the way. These are some logos of some of the stuff that goes into this project. I didn't necessarily set out to learn any of these. And I'm not an expert in any of them now, but I do see the problems that they're solving, right? I see the strengths and the weaknesses. I know which ones are good and which ones are bad, which ones I like using, which ones I didn't. And this is like a force multiplier, right? The more that you know about this stuff, the more opportunities there are for learning, right? I know how DuckDB works. I know how it kind of, the shape of it. I know how it can be clicked together with something else and where it can't. So in the future, if I have a idea or a question that might be forming, maybe it forms more quickly if I think, oh, I can use this tool for that or this one. Like the variety of stuff that you learn doing something like this is a lot. So how do we do on the optimizing the joy checklist? Pretty well, I think. Again, I didn't set out to learn any of this stuff. I fell down a rabbit hole because I was interested in the outcome. The technologies on the previous slide, they're not interesting by themselves. DuckDB, Data Fusion, Parquet files are not interesting in and of themselves. How you can use them to fit them together to build something like this is the interesting bit. And I did this by dropping everything that I didn't want to do, right? There's no documentation for this. The code quality is not fantastic. There are no tests, for example. It is a glued together hodgepodge of various things, but it works and it has a pretty website, so it's fine, right? And the idea is not, this isn't an open source project that I want people necessarily to contribute to. It's my learning and my exploration focused into something that I think is useful. The moment you feel yourself getting sidetracked or losing sight of the outcome, just drop it and refocus. Cool. Really briefly, this is the kind of chart of the various questions that I asked. Didn't even talk about all the stuff that went wrong, that I dropped along the way, the questions that I took, the directions I took that didn't work. And these are some of the future stuff, the questions that I'm thinking about. Maybe I'll ask, maybe I'll try and solve. So, you know, what's the tooling look like? Why are the pack files bigger than they should be? Why is libcst slow? And here's some ideas for potential questions that you might ask. What's the most duplicated piece of Python code ever? That involves a bunch of interesting things. What's the impact of ChatGPT or Copilot on the coding pipeline? Is there like a notable change in any way? What languages do people publish code in terms of like what natural languages? Are there lots of comments in Spanish versus English versus Chinese, for example? And why can't we just search the file contents for SQL? Why do we even need to clone a big bunch of Git? So finishing thoughts. Programming itself is not a joyful activity, I don't think. Satisfaction comes from the outcome, from building something. As you progress, those outcomes get harder to be satisfying. And doing side projects that focus only on the outcome makes it easy to fall into a loop where you learn a lot. And lastly, anyone could do a project like this. Like there's nothing innovative here. I didn't invent a new sorting algorithm. I didn't build something awesome. I glued a bunch of things together and I learned a lot along the way. And by focusing on the outcome, I think you can do the same. Awesome. Thank you.